And here's an interesting fact about hunters. So anthropologists have studied hunters, hunter-gathering societies in different places. And the physical peak that at least males have is in their early 20s, right? That's when they run the fastest. They got the best eyesight. But the best hunters in the community are 36 to 40, right? They're not as fast as those guys, but they just know, they know the track, they know the animals, they know exactly what to do in these different. And then hunting skill begins to decline because basically the physicality of things begins to catch up. And so there's this kind of cycle. And at 18, young hunters aren't even producing enough food to feed themselves. So it's not until they get into their 20s that they're actually in surplus and bringing food home for everybody else. So there's just, and you need to know hundreds at least animals. You need to know animal behavior. You got to be able to spot tracks and spoor. And there's just we're just very knowledge dependent in terms of our hunting and gathering.
Yeah. Given the what you just said, and also the experience of these European explorers suggests that you just got to know a lot of shit to make it in any sort of environment on Earth. But then there's all these other animals, and they seem so dumb, and they seem able to get by. So why did humans have such a hard time of it?
Yeah, well, so I think we offloaded a lot of stuff into culture. So in one of my Lost European Explorers, there's a case where they're in Australia and they have camels. And the camels escape, and now Central Australia has lots of feral camels. So the camels survive the Lost European Explorer challenge because they have innate instincts. They can smell water a mile away. They can detoxify foods in their own. They have a complex digestive system that detoxifies. We've lost all that, and we're worse than chimpanzees at detoxifying foods because we have all these cultural practices that do the work. So we've externalized detoxification and a lot of digestion, actually.
I had this independent researcher and internet writer called Gordon Branwen on my podcast a couple months ago. And we were discussing AI, and I asked him, so his theory is very much the brain became bigger, more intelligence. And so then I asked him, look, if it's this simple, why did it take so long for evolution to discover intelligence in the first place? And he had this interesting answer, which is that there's a very narrow, in terms of the signal that evolution is giving you, there's a very narrow gap between skills that are so useful that they should just be distilled as an instinct into your genome, and then skills that are so worthless that they're not worth learning in the first place. And so this narrow gap that's you need that generalization ability. It's not so primal that you're not going to culturally learn hunger. You just going to be in your genome. I don't know if that sounds like a interesting explanation or helps explain anything.
Well, I mean, in cultural evolutionary models, there are a typical thing would be to let genes compete with individual learning to compete with cultural learning. And it turns out the rate of change of the environment affects that. So if the environment is changing slowly, then you should put it all in the genes.
Yeah.
And if it's changing a moderate speed, then culture is the best way to go. And if it's fast, then individual learning.
Yeah.
And the idea, the individual learning is favored because if it's changing too quickly, the previous generation doesn't know anything worth knowing because the world you're dealing with is just so much different from their world. And so it's this intermediate range. So myself and others have argued that the increase in the frequency of change during the Pleistocene transition 2.5 million years ago is a change that increases the value of cultural transmission of learning from others. I'm not sure what your guest was thinking. I mean, but as our brains are not very good at solving problems, otherwise the Lost European explorers could survive. And human brain size has been declining for the last 10,000 years. So we've actually been getting dumber, fewer neurons, less computational power. So.
Yeah. Why has brain size been declining?
Well, the collective brain argument suggests that at a certain size, you'll begin farming off specialists. So because there's a store of knowledge in the society, and we can all be generalists and learn how to do all the different skills. But at some point, it makes efficiency sense for us to specialize in different skills. Yep. In order for that to be the case, though, we have to have social agreements of some sort that allow us to trade or exchange things like that. So. But then once we're specializing, we don't necessarily need as large a brain, and because we distribute the overall brain power amongst the society. So it could be that we're becoming more of a superorganism.
Right.
And you see the same thing in ants. When ants get specialized occupational casts, their individual brains shrink.
Interesting.